All right, Algebra 1, we have been through quite a few exponent rules, and now we're going to move into some scientific notation. Now, I put a little bit of this in front of you in class the other day, so we'll see how it goes. All right, so in our warm-up today, all you have to do is some simple stuff, right? Trying to get the idea. 2.8 times 10, okay, well, that means I should get 28, right? I got to move this decimal over one place. Well, now it's squared, so I'm going to move it over two places. This should be 280. You get the idea. So this is going to be 2,800. I'm going to move three places, right? This is about movement of decimal places. This is not the number of zeros. So using that idea, let me flip the script a little bit. How many zeros do you need to put on 2.8 times 10 to the 22nd? Well, so that means I need 2 8, so that's one place. So I need 21 zeros. All right, there they are. And if I just go back and put some commas in here, if I can see these pretty well. All right, there we go. There we got them. Yeah. All right. So whatever number that comes out to, thank goodness for scientific notation, right? So this is why we study scientific notation, so we don't ever have to write this unless it's some silly test or quiz question that I may ask you, just to make sure you understand how it works. All right, so quick question as we look at scientific notation. Which one's different here? I get 10 to the fifth, 10 to the ninth, 10 to the negative third, 10 to the fourth. So that one's negative, but here's 10 to the negative seventh. All right, so some of them are negative. All right, let's take a look at these. 1.45, 6.3, 9.7, 14.8, and 6. All right, so 14, this one doesn't seem okay, right? Because this number, right, if I take a look at all the other ones, those decimal points line up. Okay, and that should hopefully remind us that in scientific notation, this number here, A, has to be between 1, okay, so it should be greater than or equal to 1, but less than 10, right? It should be a single digit. This is our code for a single digit. All right, number is in scientific notation, okay. If it's written as a times 10 to the nth power, n is an integer, okay, so we have to remember that that is negative 2, negative 1, 0, 1, 2. We can go on both ways, so no decimals, no fractions. And here's what we laid out up above there. That the a value has to be a single digit. So here are some examples of things that are written in proper scientific notation. 3.4 times 10 to the 6, check, that's good. Okay, 5.4, that's good. Times 10 to the 13th, that's good. 9, okay, we could say 0.0 if you wanted to. So that works. And 10 to the negative 10, so that works as well. All right, so let's match them up. So first thing I want to notice is if I have a negative exponent, this should be a number that's really small, right? Okay, because it's written in proper scientific notation. Now the next one is, so same thing for the a value, 6.83. So this one has times 10 to the fourth versus 10 to the eighth. So 10 to the eighth should look a lot larger than 10 to the fourth. So that's what we'll have and match those up. So hopefully that was not a big deal to match those. All right, let's figure out which ones are good, which ones are not. All right, so what we'll do is kind of check them off versus maybe just highlight or find out what's wrong with any of these if there's something wrong. 4.5 times 10 to the third. Looks good to me. 0.3, okay, so that's no good. Let's get my highlighter a little bit smaller so I can draw these nicely here. Okay, so that one's no good. Then a reason is the 0.3. All right, 5.4, that looks okay. 10 to the 7th looks okay. Oh no, we got a problem in the middle. Remember, this should be multiplied. 7.5 times 10 to the negative 5th, that's good. 4.5 times 10 to the negative 3rd, looks pretty good to me, right? A value works times, ooh, I got a problem here, no good. Remember, it has to be 10 to some power, not 5. Negative 2.3 times 10 to the 3rd. Yeah, remember we said the a value, the absolute value has to be between 1 and 10, so a single digit with a decimal, but it can be negative, so that's all right. 3 times 10 to the 4th, yeah, that's good. Right? If I need to do something with it, remember that's 3.0. All right, second column, let's see how we do here. 5.4 times 10 to the 7th, that's a good bingo. 1 times 10 to the 5th, I'll take it. 32 times 10, 32 times 100. No, that's no good. 2.376 times 10 to the third. I like it. 11 is a problem, right? So 11 is no good here. 2.3 times 10 to the fifth. Good stuff. Divided? I don't think so. Not in scientific notation. And 56. All right. We have a problem there as well. So we can see some of those that are good versus some that are not. So you should be able to sort through those anytime you want. All right, our next one we have, let's see, so we're in scientific notation. Let's change it back into standard form. So it means 7, 9. So that'd be one place. So I need 11 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it just barely fit. Okay, there we go. 5, remember the decimal point is right here. So this time I want to go to the left. 1, 2, 3. So 0.123. Okay, so 0.005 will get us our match here. And 3.4. So I need 2 places to get around the 0.34. So that means I only need 4 more zeros. So 3, 3, 4, 1, 2, 3, 4. And I think it is helpful for both of us if you put those commas back in there so we can tell what's going on. All right, the next set, we want to make sure we go from standard form back into our scientific notation. So first thing is decide where the decimal is going to go. So right here, so 4.7423 times 10. That's a pretty large number, right? So I got to go 3, 6, 7, 8, 8th power. Okay, so that's why it's nice to have those commas on there. That way it's a little bit easier to count. You see why? Because when it's going to be smaller like this one, you know, we can't skip count by those 3s. So here we go. Where's the decimal point going to end up? Between the 3 and the 7. Okay, so 3.75. How do we get there? 1, 2, 3, 4, 5, 6, 7. So times 10 to the 7th, right? It can't be 7. This is a small number, so it's negative 7. There we go. So I'm going to write, so we're just going to work on transferring these back and forth. So hopefully not a big deal. 1.55 times 10 to the 6 Kelvin. It's pretty hot in the sun's core. It's even hotter in the core than it is on the surface. It's true. I asked a science teacher. They said it's true. Okay. So that means they're going to move the decimal 6 places, make this number pretty large. 155. So it's 2 places already. 1, 2, 3, 4. I'm going to put my commas in here. So that's Kelvin. All right, parasitic wasp. It is the smallest insect at the time of finding this lesson and putting it together for you. And here's a picture of it down here. Okay. Its mass is 4.92 times 10 to the negative 6. Okay, so I'm going to move one place around here. So I need 1, 2, 3, 4, 5 decimal places, and then the 4. So that gets me all 6 from the exponent, 92 grams. Okay, so that's not very heavy. I wonder if I just eat one. They're so small. How would you even know? It's kind of creepy, isn't it? That's okay. If we're going to compare numbers that are in scientific notation, this one's kind of interesting. And what you want to do is we're going to compare the oceans, but we already know that they're all properly written in scientific notation. So we're just going to do a little bit of a comparison of the exponents. So 10 to the 7th, 10 to the 7th, 10 to the 8th, and 10 to the 8th. Okay, well, something that's 10 to the 8th is automatically larger than something that's 10 to the 7th. So first thing I'm going to do is compare these two. Okay, so let's see, what are we trying to do? From least to greatest. So the smallest ocean we have, 1.41 versus 7.49. So smallest is the Arctic. Then we go to the Indian Ocean. Okay, because those were 10 to the 7th, and they're all properly written in scientific notation. And then we go to the Atlantic and the Pacific. Let's see here, both 10 to the 8th, so they're automatically larger than 10 to the 7th. The next thing we're going to do is compare the A value. And we're looking for the smaller one, which is the Atlantic Ocean. $1.06 is less than $1.80, right? So 3 and 4. So easy enough to order them based on the exponent first, and then go to the A value. Now that was nice because they were all in proper scientific notation. This one, however, is not. So what I might do is just adjust a few of these. And this is the first time we get a chance to talk about this. Now, 49.7 is a little bit too big, right? It has one decimal place too big. So I don't know how they do this in science class, but here's what I tell you, is that currently this is to the first power. And if it's too big, I do plus. How many places do I have to move is 1. So I should have 4.97 times 10 to the second. Okay, the next number I have is in proper scientific notation. Okay, so I fixed this one. This one was okay. This one is too small, so I'm going to do minus how many places? 1, 2, 2. So it should be 4.7 times 10 to the 7th. Okay, and 495, well, that doesn't have anything. So I could picture 495 times 10 to the 0 power. The decimal point is right here. I have to move 2 places because it's too big, so plus 2. So the last number I have is 4.95 times 10 to the second. Now, of course, my other option is to put all of these in standard notation or to put them in the calculator some way and try and check them out that way. But I think it's just as fast. And for what we're going to ask you to do, we might as well do it this way. Again, we want to be least to greatest. So I know 10 to the second is definitely going to be first. Okay, so 495 is less than 475. So 1, 2. The other two are both 10 to the 7th. So they're going to be 3 and 4. So let's see, $4.17 is less than $4.70. So now they're all compared. All right, and then you go down to science class. You're going to talk about Jimmy Neutron and protons and electrons and all that stuff. See what I did there? Okay, and so what's going to be the smallest number here? Something 10 to the negative 24th is something 10 to the negative 28th. The 28th, right? So smallest, least to greatest. Now these are both the same, so that means we're going to bump over to that A value. And the proton is going to be number 2, and then the neutron is number 3 as far as ranking based on grams. All right, pretty good so far. Let's start to do just a little bit more with these. Now I want you to multiply, right? So we're going to multiply 7 times 4. Well, that's 28. It's times 10 to the 5th because nothing changed there. But this number, remember, is too big. So I'll go plus 1 place because I only have to move 1 place to get it in proper scientific notation. So it's 2.8 times 10 to the 6th. Okay, let's try that again down here. This is too big by 1 place, so plus 1 place, 6.73 times 10 to the 5th. So it's not too bad. Well, what if the number's way too small, like example 3 over here? This number's way too small. 1, 2, 3, 4 by 4 places. So 4 places, but it's too small, so subtract. So 3.24 times 10 to the negative 10th. All right, so that's how we translate some of those around. Now, got an extra one over here because the 6.51, that's totally okay, but we highlighted earlier today that this is not okay. So this is where your rules of exponents fall into place here. So 6.51 times, well, I need this to be 10, and it's currently to the 7th power, but 100 is what? 10 squared. So what do I do with a power to a power? So 6.51 never has to change. That part has been okay the whole entire time, but it has to be 10 to the 14th. 10 to the 14th. Okay, so power to a power, and if it's not times 10, we can make that adjustment. Now, so a mistaked one up before when we went through the sorting, it was times 5. We can't make that adjustment. But if it's 100, 1,000, 1/10, if it's anything like that, we can make an adjustment and deal with it that way. So there's your extra one on the side. Okay, if that wasn't on your notes, put it on there. It's a good one. All right, do you know how to do these? All right, I hope so. So here's your quick lesson check, and then we'll get this divided out into some homework at some point once we check in and make sure everybody's good in class. All right, that's scientific notation. Bye.